This is video 11.4.1, and it's to summarize what we talked about in class and how to find the slope of the tangent line or the instantaneous velocity. Okay, so we're looking as close as we can to a given curve and zooming in on that point. So let's just quickly review. It's all about slope and the slope formula, but we don't want to work with secants anymore, where we go from one point to another. We want to try and find a tangent line. So I would rather find this tangent line that would only go through this point and none other in the near region. So we're going to talk carefully about that, but it goes all back to slope. So let's review the formula and what we're going to be finding. So it's all about slope, and we're going to be looking at the slope of a secant line where h is the horizontal distance and the rise would be the difference between the y's. So we're going to take the difference of f of a plus h and minus f of a. Okay, we're looking at 2 points that are h apart, and then there, of course, we're going to find the difference in the y's. So this formula needs to be memorized, that we're always going to do f of a plus h minus f of a over h, because that's the rise over the run, or the change in y over change in x. And what we're going to do, remember, is look really, really, really small. We're going to think about h turning into 0. And of course, h can't be 0 because we'd have a denominator of 0, but we're going to narrow in on that small value so that we can have a really tiny triangle that will hopefully be just a tangent triangle, just barely nicking the edge here. It would be the tiniest little triangle with h being extremely small. So let's take a look at an example on how we're going to do that. What we're actually going to be finding, by the way, is a limit. We're going to be looking at a limit as h goes to 0. That's what this says right here. The limit as h approaches 0. We're going to be narrowing in. Notice all these secant lines that are drawn here. They get closer and closer to a tangent. The tangent would have 0 height because we're narrowing in and we're getting closer and closer to the original value a. So we're going to narrow in until our our h value, our horizontal run across is 0. So we're really looking at a limit. So let's take a look at this to make sense of it. This is just kind of a lot of math talk, but let's look at an actual example so you can see what I'm talking about. So if we're looking at this problem here, we're looking for the slope of the tangent line to the graph of f of x equals 2x squared plus 3 at the point negative 2, 11. So here's the formula we're going to be using. The formula for this slope is always the limit as h approaches 0 of the slope formula that we developed in class today. We're going to look as h gets closer and closer to 0. That's the formula for the slope of the tangent line. So m tan, that's why I did that, m tan, m for slope, tan for tangent. So in our case, we always want to remember that a is the x value that we're looking at. So in our case, a is negative 2. We're going to find f of a plus h, so we're going to find f of negative 2 plus h, subtract f of negative 2, all over h, and we're going to find the limit as h approaches 0. That's my goal here. That is what the formula is asking me to find. The slope is found by finding that limit. So let's talk about finding this value first. F of negative 2 plus h. Remember, that means that negative 2 plus h is going in for x in my equation. So I'm going to copy 2 and then negative 2 plus h squared, because that's where the x was, plus 3. That's f of negative 2 plus h. F of negative 2, we're going to be subtracting f of negative 2, which is, and I'm going to use parentheses here, negative 2 times negative 2 squared plus 3. The reason I use parentheses is you got to be really careful. This is big. This is key. This whole thing needs to be subtracted because that's what this is saying. Subtract the value of f of negative 2. So the second part here is going to be easier to calculate, the guy in parentheses in blue. The other part's going to be a little bit more work. And of course, this is still over h, and we're still taking a limit as h approaches 0. So let's calculate this piece right here so we can have that done. We're still going to have it over h. But this value here, let's see, negative 2 squared is 4 times 2 is 8 plus 3 is 11. So we're going to be subtracting 11. Hopefully that makes sense because, remember, when you plugged in 2, we got 11. Negative 2 comma 11 was a point, so I kind of already knew the answer there. Now let's work this part out on the left. This is our first thing to work out. So we're going to do negative 2 plus h squared. Remember, that's a generic rectangle. That's negative 2 plus h on both sides. I'm timesing it by itself. I'm going to do that in my head quickly. I'm going to get 4 plus negative 4h plus h squared. But don't forget the rest of my equation. Remember, that was times 2 plus 3, because that was the 2 and the 3. So being careful here, don't lose anything. I almost lost it until I looked at it and realized something was up. Let's take a look now. We're going to distribute the 2. I could probably do this math right here as well while I'm at it. So I'm going to get a minus 8, because 3 minus 11 is negative 8. Distributing the 2 here, I'm going to get 8 minus 8h plus 2h squared. And we're still taking the limit as h approaches 0. And continuing to simplify just like we did in class, let's see, these 8's cancel out. We get negative 8h plus 2h squared all over h. And we're still taking the limit as h approaches 0. Now is the point where I simplify. I can divide each of these by h, and I get negative 8 plus 2h, and I'm still taking the limit as h approaches 0. Now I'm ready to plug in 0. I'm plugging in 0 for h. I'm sorry, that's gotten a little sloppy over here. I don't want to lose my negative. The limit is h approaches 0 of negative 8. Now I'm ready to plug in 0 because I can. It's legal at this point. So I'm going to plug in 0 to find my limit. I get negative 8 plus 0. So the answer is negative 8. That's the limit. That is the instantaneous velocity, or the slope of the tangent line, at negative 2. Quick way to check your work would be to look at the graph. You should see the graph going downwards fairly quickly. Negative 8 is a slope. It's very quick and downward. Okay? Think of what you would do to graph negative 8, the slope. You could also graph a line with the slope of negative 8 to look at it and see if it works. And we'll talk more about that in class, but now I just want you to see the process and what you'll do for your checkpoints. Let's take a look at another example, an example that's actually a little bit more meaningful because it's something we've looked at before. So remember when we looked at this firework problem, and we already found the rule for this. There was a couple ways to find the rule. One way is the vertex form, what I've written here, f of x. But if we're asked what's the instantaneous velocity at 6 seconds, remember that means that I'm going to ask what is the limit as h approaches 0 of f of 6 plus h minus f of 6 all over h. That's the formula for instantaneous velocity, or the slope of the tangent line, and they are, of course, synonymous. Now I'm going to plug in and calculate these things out. So let's plug in f of 6 will be fairly easy. I'm simply going to plug 6 into my function here and do the math. And I'm not going to bore you with that again because I think that's not important for you to see me punching into a calculator. But I'm going to get minus, because we have subtract, and I got 190. I look at my graph, and that seems about right. Here's 6, somewhere in here. Yeah, it's definitely close to 200. Now I'm going to do f of 6 plus h. So this one's going to take a lot more calculating. I'm going to copy my limit statement. But I'm going to do f of 6 plus h, so that's not going in for x. So I'm going to copy the negative, parenthesis, 6 plus h, minus 10.5 squared, scoot this guy over, plus 210.25. That whole thing represents f of 6 plus h. And it's still over h. So I have some work to do in simplifying this. And again, it's just pure algebra at this point, just knowing how to square things. Let's simplify the inside first. 6 minus 10.5 is negative 4.5. So let's write this as h minus 4.5. We need to square this and tack a negative on everything. So let's start with squaring it. We'll leave it in parentheses and we'll square it. Again, I'm not going to bore you with this generic rectangle, but you'll get h squared minus 9h And then you'll have 4.5 squared, which is 20.25. So plus 20.25. I still have all of this other stuff here. I'll put a different color for you. I'm going to simplify that just to save myself some writing. So 210.25 minus 190, and I get 20.25 positive. All over h. Still taking the limit as h approaches 0. Now we'll simplify the top a little bit further. So minus, that would mean everything gets flipped. So negative h squared, positive 9h, negative 20.25, plus 20.25. Notice those things are going to cancel. All over h. So these two things are gone. And now we're ready to do the simplifying step. Negative h squared plus 9h, all over h. Limit as h approaches 0. Last but not least, simplifying, I'm going to get negative h plus 9. The h's are gone, but we're still taking the limit. I'm sorry, the h on top is gone because we simplified. Now I'm ready to plug in. 0 plus 9 is 9. Correct answer here is 9. The slope of the tangent line is 9. The instantaneous velocity is 9. Again, look, it's fairly steep. It's going upwards. Slope of 9 seems about right. Definitely not 0, and it's definitely not negative. So 9 is the correct answer for this second example. So now you're going to give this a shot with two problems. Do your best, but try the formula with these two equations that you're going to see in the checkpoints. So in the checkpoints, you're going to find the instantaneous velocity of the rocket, actually firework, I guess. So use that same rule and try it on your own at 20 seconds. Use the graph that I have here to kind of picture it. 20 seconds is really close to 25, so we're somewhere in here, and we're looking at what's the instantaneous velocity there. Make a prediction. Think about what you think the velocity would be, and then try to use the formula that you saw earlier in the video and the examples. The MCQ is a little bit more like the other examples. So do your best on these. Bring your questions into class, and we'll see you then.